So hello everyone. I would just like to continue on the discussions for the mechanisms of toxicity, which is steps 2 to 4. So just to recap, on step one, we have a four-step framework, right? So our step one involves site of exposure. So that is um, where the toxin or the toxic agent comes from. So it can, or you might be exposed dermally or through your GI tract or through your lungs, and it will go through an absorption process, which is crossing biological membranes, and distribution and reaching the target site where there are molecular interactions. So, we have here, this is also part of step one. We have detoxification and detoxification processes. So, the toxification is a process of metabolism in which a metabolite is more toxic than the parent drug. And detoxification is a biotransformation that eliminates an ultimate toxicant. So, when you say toxification, this is when an inactive metabolite or toxic agent is transformed or a pro metabolite is processed and turns into a more toxic um, agent. While detoxification is the opposite, that is a metabolism that eliminates the ultimate toxicant or the toxic metabolite, which was synthesized in your body. Okay, so for the toxification process, we have the formation of electrophiles, formation of free radicals, and formation of redox active reactants. When you say formation of electrophiles, that is produced. So this is the process. First, there is a formation of electrophiles where there is a production of oxygen atom, and then it withdraws electrons from the atom attached to and forms a conjugated double bond. So when this double bond is created, there is then a polarization by electron drawing effect of an oxygen or as a result of heterolytic bond cleavage. So basically, formation of electrophiles, there is an insertion of oxygen atom and it withdraws electron, resulting to a polarized electron withdrawing effect and is a result of electrolytic bond cleavage. Next, we have the formation of free radicals. So by accepting an electron, losing an electron, or by homolytic fission of a covalent bond. So once there is a formation of electrophiles, it will also form free radicals. So we will tackle on free radicals later. And formation of redox active reactants. So when you say redox active reactants, those are the toxic metabolites or um, the components that makes up the toxic or the toxic metabolites. Okay, we have here the detoxification process. So the first one is the phase one and phase two metabolism. So it will undergo phase one and phase two metabolism. Next is detoxification of nucleophiles, conjugation at the nucleophilic functional group, detoxification of electrophiles, detoxification of free radicals, and detoxification of protein toxins. So basically, that is how the detoxification process works. So there is a detoxification first sa nucleophiles, and then to electrophiles, and then free radicals. Then lastly, detoxification of protein toxins, which is then excreted through your body, outside sa imong body. And it follows the process, the phase one and phase two metabolism. Okay, so when you say toxification, it is also termed as metabolic activation. Again, this is a conversion from electrophiles. Sorry, this is a conversion to electrophiles or free radicals. Okay, and then the detoxification process naman, that is a neutralization of reactive species such as conjugation. Okay, so we will proceed with our antioxidants. Okay, can you remember this one class for vitamin A? These are its functions. Usually for vitamin A, it protects molecular membranes and prevent glutathione depletion. Glutathione is important for your oxidation process. So it excretes or helps excretes your free radicals outside your body. So C vitamin A, it helps prevent glutathione depletion. And vitamin C, vitamin E, these are usually paired together. Vitamin C boosts the effect of vitamin E. So that's why both of them, when taken together, they produce an antioxidant effect. So for vitamin C, it protects the DNA, RNA, protein, lipids, and helps in regenerating vitamin E. For your vitamin E, it prevents glutathione depletion and remember this one, protects cellular membranes. Okay? Vitamin E is very important for your cellular membranes. Carotenoids, it is a free radical scavenger as well as lipoic acids, phenolic acids, and selenium. Selenium naman, this is a cofactor free radical detoxifying enzyme. So this is paired together with detoxifying enzymes and it maintains the gluten levels and it also helps in vitamin C and vitamin E regeneration. Okay. So, instances when detoxification become insufficient. This is when toxicants may overwhelm the detoxification process, leads to saturated detoxification enzymes, depletes cellular antioxidants, leading to accumulation of ultimate toxicant, as well as reactive toxicant inactivates a detoxicating enzyme. Conjugation reactions can be reversed. Detoxification can generate potentially harmful byproducts. So when you say there will be times that there will be a disruptions in the detoxification process, when okay, here are um, four situations or tendencies. So first, your toxicants may be overwhelmed with the detoxification process. So it will lead to saturated or accumulated na detoxification enzymes. So when detoxification enzymes are elevated or nag-accumulate siya, it will deplete your cellular antioxidants. Okay? Instead na si toxicant lang ang iyang eliminate, ma-appeal si antioxidants or enzymes that are very important sa imuhang body systems. Next is a reactive toxicant inactivates a detoxicating enzyme. A detoxicating enzyme, ano siya, ang help di ba nga mag-process sa detoxification process. So, if there is a toxicant, it will interact with the enzyme, causing its effect na manal siya or no effect at all. And then conjugation reactions can be reversed. And we have last one, detoxification can generate potentially harmful byproducts. Okay. Okay. Step 2, reaction of ultimate toxicant with target molecule. So step 2, these are the processes, interaction with the target molecule and alteration of biological environment. So this is a photo from your book. The first one, if you could see here, we have attributes of target. So a target or a target molecule which a toxicant would um, attach itself or as I'm exposed is it will base on its reactivity, accessibility, and critical function. And then the reaction types or how it binds to the target molecule, we have non-covalent binding, covalent binding, hydrogen abstraction, electron transfer, enzymatic reaction. And then the outcomes, we have dysfunction, destruction, and neoantigen formation. Attributes of target molecule. Okay. Again, it will base on its reactivity and its accessibility. Okay, ultimate toxicant should react with the target and adversely affects its functions. So it will alter down its functions. And also, a toxicant should reach the effective concentration at target site. So it should be concentrated enough that when it will reach the target site, it will elicit its effects. And lastly, it alters target in a way that is mechanically related to observed toxicity. So let's say reactive na si target molecule. Aside from being reactive, it once there is an exposure sa toxicant, the target molecule should be altered in a way that it will be observed as a toxicity, or it will show signs that there is observed toxicity. Okay, we have the types of reactions. We have the non-covalent binding, covalent binding, hydrogen abstraction, electron transfer, enzymatic reactions. Okay, and effects of toxicants on target molecules. Dysfunction of target molecules. So, once there is a reaction, sige, let's say the toxicant has already reached the target site or molecule, and it will demonstrate either one or two of these types of reaction, and then it will take its effects. So it is categorized into three. You have dysfunction of target molecules, destruction, and neoantigen formation. Okay. First one is dysfunction of target molecule. It activates protein target molecule by blocking neurotransmitter receptors or ion channels. And it will inhibit mitochondrial electron transport chain and enzymes. So what happens is that there will be no cell reproduction, there will be no synthesis of new cells because gi-block ang neurotransmitter receptors. So it will disrupt the overall like na process, cellular process sa imuhang target molecule. We also have here next the destruction of target molecule. It alters the primary structure of endogenous compounds by cross-linking and fragmentation, and it will create degradation after chemical attack. So once there is dysfunction as a target molecule, it will destruct by altering the endogenous compounds. So katong mga endogenous compounds found within the cells, it will be disrupted through fragmentation or cross-linking, causing chemical attack or degradation after chemical attack. And lastly, we have neoantigen formation. This is a covalent bonding of xenobiotics or their metabolites to evoke an immune response. Haptenized proteins, antibody, mediated response. So neoantigen formation, this involves hapten, that is the term for metabolites or the product of covalent bonding of xenobiotics. Okay, so this haptenized metabolite, this haptenized molecules, they will evoke an immune response. So haptenized proteins, antibody-mediated response. So once there is haptenized proteins or molecules, what will happen is there will be an immune response, usually carcinogenic or neoantigenic effect. Okay, kindly just read on this one. Okay, this is a flow chart. So we have here role of the organic molecule, diba? There are two categories, cell regulation and cell maintenance. So si cell regulation, diri mag-affect si toxicant, like there is dysregulation of gene expression, dysregulation of ongoing cell function, and then cell maintenance naman, impaired internal maintenance and impaired external maintenance. So, just read on this one, class. I will not be very particular in this. So, cellular dysfunction and resultant toxicities. Okay, so toxicant induced cellular dysfunction. What will happen if there is cellular dysfunction? It will result to dysregulation of gene expression and dysregulation of ongoing cellular activity. So, this is just the effects, dysregulation, transcription, signal transduction, most ano sa cell or sa gene expression and cellular activity or overall na cell process. So it will disrupt cellular function or processes. Okay? We have this one. I think this is found in your book. You can just read on this one. I'll not be very particular. I just wanted to understand how, like let's say, dysregulation of gene expression affects transcription or results in transcription. Or sorry, it will affect pala the transcription, the gene transcription. Okay. And then here in this regulation of ongoing cellular activity, we have electrically excitable cells. We have activity of other cells. You can just read on this one. Um, Alteration in neurotransmitter levels. Chemicals may alter synaptic levels of neurotransmitters. So this one, I've mentioned it earlier, there is alteration of cellular function. So it will interfere with their synthesis, storage, and release. Okay, once there is toxic exposure. Okay, this one is very understandable. So you can just read on this one. And then we are on step three, cellular dysfunction and resultant toxicities. So after there is, um, so once there is interaction with the target. So step 2 na to, class is C, interaction with the target. So again, step 2, that is the pivotal molecular event where the toxicant binds to an endogenous molecule. So that's why we have here mga effects. This one, sorry, this one, these are the effects. And then we are on step 3. Okay. So, sorry, because this one pala, is regulation of cellular function that is under na step 3 na pala. Okay? So, covalent, let's see, cellular dysfunction ito. Toxicants cause toxicity by altering gene expression or ongoing cellular activity. So, this was categorized into gene expression and dysregulation of ongoing cellular activity. Okay, can just read again. Mm, okay, this one. Toxic alterations of cellular maintenance. There is there are results of impairment of internal cellular maintenance, which is a mechanism of cell death and impairment of extracellular maintenance. So class, remember for cellular dysfunction for step 3, just remember na there is. So, sa step 2, di ba, is nag-attach na si toxicant to the target molecule. So, sa step 3 naman, this is where the toxicants would cause toxicity. Okay, ang iyahang mechanism is it will alter the gene expression and ongoing cellular activity. Okay, so just remember here sa step, sorry po. So, just remember here sa step 3, just remember here sa step 3 that, um, sorry, I lost it. Okay. Remember here sa step 3, there is toxicant na na-attach na to target molecule. So you will expect that there is a destruction of the cellular process, the cellular components. So the end results for step 3 would be depletion of ATP, sustained rise of intracellular calcium, and overproduction of ROS and RNS. Okay, step 3 again, cell death mechanism. Okay, we have here, okay, for cell survival, it must synthesize endogenous molecules, okay, and assemble macromolecular complexes, cell organelles. maintain the intracellular environment, and produce energy for operation. Chemicals that disrupt these functions, especially the energy-producing function of mitochondria in protein synthesis, jeopardize the survival and may cause toxic cell death. Okay, that is mechanism of cell death. So, we have here the toxic alterations of cellular maintenance. So, impairment of internal cellular maintenance. So, first we have the depletion of ATP. Okay, next is so your ATP is the protein, di ba, sa mga cell. And then sustained rise of intracellular calcium. Okay, when there is a sustained elevation of your calcium, it will result to depletion of energy reserves, dysfunction of microfilaments, activation of hydrolytic enzymes, and generation of ROS and RNS. Okay, so next we have the overproduction sorry, overproduction of ROS and RNS. Okay, just to clarify, class, reactive, so CROS, it stands for reactive oxygen species, and RNS stands for reactive nitrogen species. Okay, so these are highly reactive molecules that are generated during cellular metabolism. Okay, if they create two activities, so it depends on the level. So on low levels, they act as signaling molecules. But when there is accumulation, such as this one, overproduction of reactive oxygen species and reactive nitrogen species, they will cause oxidative or nitrative stress, leading to DNA damage, protein dysfunction, lipid peroxidation, and cell death. Okay, that will be the result. So, remember, class, for mechanisms of cell death, we have the apoptosis. That is a programmed mechanism wherein this is part of if there is overproduction of calcium, diba? So it will also increase your levels ROS and RNS. So there is a result which is apoptosis. That is a programmed active process for cell death. We also have necrosis. That is accidental. Okay. So apoptosis is programmed, necrosis is accidental. And we have inflammation. Okay. Inflammation may be um, correlated with necrosis. So this is high, inflammation is very high during necrosis. Okay, just remember lang mechanisms of that: apoptosis and necrosis. Toxicants typically trigger necrosis via ATP depletion or sustained calcium levels or sustained elevation of your calcium levels. Okay, we are now in step 4. That is the inappropriate repair and adaptation. Okay, biological systems possess mechanisms to repair damaged molecules and cells. Okay, we have here the molecular repair, cellular repair, and disrepair. When you say class molecular repair, that is DNA excision and protein refolding. Okay, next naman is when you say molecular repair, more on ito siya, molecular repair, like protein refolding, mag-generate or i-repair ang, let's say, na damage or na dysfunction molecule. Okay? Cellular repair, this is the autophagy of damaged organelles. Okay? So again, cellular repair is the autophagy of damaged organelles. So when you say autophagy naman, that is the process of um, intracellular degradation or recycling system, or in short, self-eating. Okay, so damaged organelles, they eat itself, or like it recycles, or it follows like a recycling system. It breaks down their own dysfunctional components to maintain. Usually, autophagy happens when there is, as mentioned, damaged organelles, and when it recycles itself or when it eats itself, it will break down their own dysfunctional or damaged components and survive stress sa ilang environment and to maintain homeostasis. And lastly, we have the disrepair. It leads to chronic pathologies such as fibrosis or carcinogenesis. When there is uncontrollable na disrepair or chronic na siya, it will then lead to fibrosis and carcinogenesis. Okay? Okay. Molecular repair, this is the reversal of thiol oxidation and DNA methylation, removal of damaged units with replacement by newly synthesized units, degradation followed by resynthesis of damaged structures. Okay. This one here again, cellular repair, it's self-eats or self-eating process to recycle damaged organelles and to survive stress and maintain homeostasis. Resynthesis of damaged structures. And okay, lastly, we have tissue repair. So this is the active removal of damaged cells via apoptosis. Okay, and then replacement of lost cells via mitosis, so there is cell reproduction, and then resynthesis of extracellular matrix. Okay, um, this one here plus active removal of damaged cells via apoptosis. So that is, as mentioned, that is the programmed cell death. So Marashag, it's a normal process or it has to happen during cell death. That is cellular suicide. So it will remove damaged cells. This is to make way for new cells to reproduce. So there will be enough space or um, enough capacity sa imong body nga mag-get og new cells. So that's why here the second step is replacement of lost cells via mitosis. So once there's apoptosis or programmed cell death, it will then synthesize new set na pod sa imong cells and then resynthesis of extracellular matrix. Okay. Toxicity resulting from inappropriate repair and adaptation. Again, we have the tissue necrosis and fibrosis and carcinogenesis. Okay, when you say tissue necrosis, this is tissue death, fibrosis, carcinogenesis. So, once there is toxicity, if your body or your cell were not able to recover or was not able to repair itself, it will most likely lead to this three end results. Okay, and this is what we would not like to progress. Okay. Okay, so our last slide, toxicity is not an inevitable consequence of toxicant exposure. Okay, inevitable means when you say toxicity, sorry, toxicity is not an inevitable consequence. So toxicity daw is malikayan gud siya. It is something that we can prevent or this is very preventable because your toxicant exposure or your exposure it can be prevented, you can reverse it, you can compensate it by such mechanisms. Toxicity develops if the toxicant exhausts or impairs the protective mechanisms or overrides the adaptability of biological system. The real toxicity happens when your body, once exposed to toxicity, is not able to recover or to repair itself once there is resultant effects from toxicity or exposure to toxicants. So we want to prevent it from that step. We don't want this to happen. The last step because this is very let's say crucial and very life threatening na siya. Okay? So, this is your step 1 to step 4